Hello, YouTube viewers. Welcome to my show, Future Friday. In today's episode, we're going to talk about LiFi, aka light fidelity. So let's dive right into it. Well, first you have to understand this. Our future is becoming more and more wireless. We want wireless technology, and the reason for that is because every Tom, Dick, and Harry, and their grandma and their child are using internet. So we need data. We are consuming data like there is no tomorrow. So at this point in time, wireless slowly becomes a must. To think of it this way, like in my family, there is like three mobile phones. Is it practical to connect all these three mobile phones using Ethernet? Not really. So we have to go to wireless system. On top of that, even though every person and the number of people on this planet is not exploding anymore, it's not like oh, we went from 2 billion to 6 billion and we are going from 6 to 20. That's not happening anymore. Even then, the amount of device that each individual is carrying is growing exponentially. So what we are entering into is classified as Internet of Things or IoT devices, basically from your smartwatch to your refrigerator to your light bulb to every god knows every Tom, Dick, and Harry thing is going into internet. And all of those combined inherently in some in a scenario where you have like lot of device in a single household. Heck, even in my basic household, there is like two television that is connected to Ethernet, and one 4K set-top box that is connected to Ethernet, one desktop that is connected to Ethernet, and three mobile phone. So you get the idea. Like, and I'm reasonably sure most of you may have even more than this. So we have to go to wireless. Otherwise, having server room in your room is not practical. So why the heck we cannot use Wi-Fi? I'm like, we are using it. Why the heck? What's the issue with that? Well, Wi-Fi has a lot of speed issues. Basically, it's not very fast. Specifically, if you are using 2.5 gigahertz, 2.5 gigahertz is basically give or take maximum capacity of 60 Mbps, and that's lucky case scenario. That's like if everything is working properly, that's 60 Mbps. And if you want, like, there is a very good chance nowadays many people have connections that are faster than that. Heck, Geo Fiber is starting connection at speed is 100 Mbps, and it can go as high as 1 gigabyte per second. So let's say I have connection speed of 250 Mbps. How the heck I'm going to get that in mobile phone? I have to switch to 5 gigahertz, and 5 gigahertz does not allow you to go to gigabyte. It only allows you to go as far as 443, something like that. That is the maximum. So that is the reality. Like, the inherent backbone is not very fast. Then we come to insecurities, because Wi-Fi is inherently goes everywhere. So let's say I'm using Wi-Fi here. What happens behind this wall? I do not know. Somebody may be there, like Wi-Fi snooper and things of that nature could be there. So it's quote unquote unsecure. On top of that, it's even though it's designed to handle multiple people, we exceeded its ability. Basically, it was designed to handle 3 or 4 devices. We starting to put 20-30 devices on top of that. So in a stadium, even though they try to cover it with access point and do their best, it inherently cannot keep up. So we reach the maximum limit. It's like it simply cannot keep up anymore. Now, so what is the idea of LiFi? LiFi is basically somebody came up with the idea. It's like, we are using radio wave. Why not go from radio wave to basically optical system? So that's the reality. Go from radio frequency to into visual spectrum. And we are using LEDs anyway. Heck, even cars lights are finally starting to switch into LEDs, at least for brake lights and all that. And all luxury cars come with LEDs anyway. So we are moving to LED. Now, why that is important? Think of this way. Could you do this with a bulb in very slow rate? Yes, but you cannot do very fast, simply because bulb has filament takes time to heat up and time to cool down. So even if you send signal to 1000 hertz of signal, turning on and off, it will simply not do anything. It will just look dim to you. I mean, like, that's the fundamental dimming circuit of pulse width modulation. So you can't do much with that. However, LED is inherently a semiconductor, so it can be switched on and off very quickly. Heck, you may have a TV, something like this, which has a basically optical audio output port that is doing the same thing. So somebody came up with the idea, instead of we have optical fiber network as a backbone of internet from 1970. How about we remove the fiber from it? So that's the idea. LED can allow you to flicker very fast, and okay, LED is the cheap part. We got it. We really want to have something cheap. What about the receiver side? How the heck you gonna receive that signal? Thankfully, solar panel can also react quite quickly. So solar panel can actually receive those high frequency, and you can decode that in voltage fluctuations or in ampere output. You can literally decode. Oh, I'm getting this. So you can easily extract the data. So receiver and transmitter, both of them can be made out of cheaply available things. No extra hoo-ha requires, no radio required, nowhere you have to like in OnePlus cases, like they have to engineer a lot in order to create the antenna in such a way that they give you good reception. So that's the reality of it. Like your lamp on top of it, like in my case this lamp and street lamps and all that jazz can be used. Light fidelity, that's the reality of it. So okay, what will be the benefit of going into light system? Well, first people will say is very high throughput. The pipe is very fat. Basically, you can send a lot of data, and you can, like, the amount of throughput you can expect is much higher, and it's almost like connecting to Ethernet directly, and it's gonna be super fast. Again, light speed, so to say, and it's gonna be 100% secure. Now that is very desirable to many places, specifically corporate environment, because corporate espionage is a real thing. It's a real threat. Like if you're gonna sell to a corporate, it's like, dude, install LiFi and nobody can basically steal your secrets easily. They'll be like, shut up and take my money. Again, even if it can be reached, if it's 10 times harder, they're like, yeah, that's fair enough, because everything can be broken if you have enough time. But again, if LiFi gives you one extra layers of protection, you're like, and then you wanna have full coverage. Why? Because everything is slowly moving to LED. So your street lamps are moving to LEDs, your car lamps are moving to LED. Everything can act as a transmitter and receiver. So that's the whole idea, and it's not dangerous, because there is a hype around our radio electromagnetic spectrum that is dangerous. Well, that's absolutely true if enough of it is present, because again, we use that to cook our meals in a microwave oven. Your mobile phone uses quote unquote the same spectrum, only difference is it does not have the enough energy. So that's the promise of it. Like, we have light, we are moving to LED lights anyway. Why not make the light work into double duty, so to say. Now, what happened with the reality? This all started in 2011 with a professor, and in 2015 they were like, we are 3 to 4 years away from market production and all that jazz. So what happened in reality? In 2017, the first product that I could find so far was pureLiFi system came out, and it was like, hey, connect it to your LED fixture, and it's gonna become a transmitter, and you're gonna have a receiver on here. Now again, if you're familiar with the internet, you understand it's receive and basically dual bandwidth. You cannot be just like receiving. It's not a TV. You have to transmit also. So it will have a infrared beacons, quote unquote, and that will basically on rooftop you will also have another infrared system. Now, this was in 2017. In 2017, if you had like any kind of decent money, you could have easily got, like, I bought it and it was quite cheap. I got like 5 gigahertz Wi-Fi system, and that was capable of pumping 100 Mbps. And if you had like gigabyte connection, it was feasible. Like I specified, like you can go as high as 400, and that was back in that day. This puppy 43 Mbps. That's the reality of it. Like they were selling gigabyte per second. In labs, we have achieved 200 megabytes per second, 500 mega, 100 gigabyte per second. The actual product that people can buy was 43, and that's the theoretical maximum. It never reached that fast. So what happened? And okay, this is like a megabyte class department. What about gigabyte? Like if you are working in a corporate environment, yes, they are there. Like they actually made a product that can allow you to do that. The cost is stupid. Basically, it's don't even ask about it. Cost is stupid. And the reason why people got this delusional idea that it's light, we're gonna have so much oomph out of it, is simply because people thought we're gonna do frequency control. Now light is a spectrum. You stretch that spectrum. How you have basically any electromagnetic spectrum, you can stretch it out. So people thought same way we control a radio. Basically we are like, okay, be in 2 gigahertz, be 2.5 gigahertz, be it 5 gigahertz, and even in those gigahertz, it's not like 5.0 done. It's like 5.1, 4.9. 5.3. We have a lot of fine-tuned control on that. We can do that with basically light also, and light can flicker on and off very quickly. And if we can do that with multiple spectrum, because again there are millions of spectrum in it, that's why rainbow does not have like banding issues. Rainbow is like completely smooth. So again, let's say even if you can do with 5 or 6 on a white light with a normal prism, you're gonna get YOLO speeds. But that cannot be done, simply because the way to do that is to have lasers, and we utilize that. That is the backbone of our internet infrastructure. So you will see something like this, a block diagramming everywhere, where you will, if you want to understand, is just type wave, what is that? Yeah, wavelength multiplexer. I'm saying the elevation, why the heck, wavelength multiplexer. So let's say you have a big database and you have to transmit a lot of data. I'm talking terabytes per second. How the heck you gonna do that? Well, you're gonna parallelize as many things as you can. So you will have one basically violet channel that's like, let's say, dedicated for one transmission. You're gonna have blue, will dedicated for one receive, another green that is dedicated for one transmission, yellow another for receive, and red for transmission. So you can send parallel data back and forth very quickly, like lightning fast. Now this is the real thing. This is the fundamental backbone of our internet, but it requires fiber. You cannot do that on a light system, and the reason for that, the moment you do that with lighting system, the light color will change. We are susceptible to these kind of changes. So let's say red started to go down because you're flickering the red channel, the light will start to flicker in color. You will notice it. So again, it was like a marketing hype. Nobody actually wanted to do that. People knew this cannot be done, but marketing hype, self-sustained itself, and you're like, light has so much frequency. Yes, absolutely, it does. That is why we use it in our optical system. That is why internet runs on this, but it is not feasible to do on a wireless system. And then the actual reality happened is like the first question people will ask is, what happens if you turn off the light? Then they're like, yeah, let's just add a infrared system. Now, if you are old as me, aka around 30 years, you must be familiar with mobile phone used to come with infrared, like before Bluetooth was a thing. So it's again, you're back to square one. Why the heck you, after like so much R&D, after so all that, you end up in the same place? Now why infrared? Simply because ultraviolet is dangerous to human skin, and optical spectrum, we will simply see it. You have to go to infrared. That's the only spectrum. So then it becomes a useless thing. It's like, why the heck you want to control the LEDs? Like, why the heck use LED? Just use the infrared transmitter and receiver, just call it that. And then there are hidden details, like I'm not sure about that. Like I tried to research that exact detail in this company site. There is a probability that the speed, if you have only basically infrared going up and down, it's not very fast. Now again, I can understand that is called stupidity in design. It's like, if you have to use infrared as a backup, just use that as your primary system, so you don't have to worry about, you don't have to add to your LED fixture and all that. It will become an independent system, because you have to have an infrared receiver anyway. No matter what you do, you have to have infrared receiver. Might as well just make a complete system. Yeah, it's a infrared input and output, but does not sound cool. That is why, like, this, the whole idea was like stupid. Like, this is same what your basically TV remote does. It's just much faster version of that. Inherently stupid idea. I mean, like, the spectrum control is awesome and we do that, but you can't do that on a visual system, because again, color will change. You bought a white LEDs, it's supposed to be white LEDs. It's not supposed to be like, RGB LEDs inside that they're flickering. So what happened to Wi-Fi? Again, people had issue with Wi-Fi. Again, Wi-Fi association is not filled with dumb people. They also improved the Wi-Fi. So we are talking about in 2020, the newest standard Wi-Fi 6. Again, it's available. It's not something that, like, may come out. It's available right now. You can buy it. There is a good chance your mobile phone already have it, if it's a mid-range or higher end phone. So the latest development in basically Wi-Fi happened is like, we no longer have omnidirectional system. Basically, you bought this router, it has 4 antennas, and it's no longer like sending signal everywhere. That used to be the old way. So what is happening now is what we call beamforming, aka phase shifting. So think about this: your antenna, 4 antennas are acting like this. You can make sure the signal only goes like this, or like this, or like this. Basically, your signal can follow wherever the receiver is. That's the magic of it. And like, it used to be developed in 1970s and for ICBM tracking and using radar system, but now the technology is cheap enough that it can be employed in routers and your 5G mobile phone. That's how it the technology works. So we solve the issue of, like, signal dropping, because it's reinforcing and cancelling out everywhere else. You're getting clean signal to where you want to be. Like, it's no longer wasting energy. It's like, you want signal there, I'm gonna send signal there. That's it. Like, it literally happens in 3-dimensional space. So you can have like, there is a laptop there, send signal there. There is a mobile there, send signal there. It is done. Like, this technology exists right now. Then there was always an inherent issue with basically Wi-Fi system. Wi-Fi was simplex system. Basically, it either could send data or receive data. It could not do both. Ethernet can do the both, but Wi-Fi cannot. They fixed it. Now there is a multiplex system. However, because again, they kind of late to the party, so to say. So now it can do that, send and receive with multiple users simultaneously. So your router can be in your home and it can handle at least, like, any basic Wi-Fi 6 router can handle at least 12 people using input and output at the same time. Let that sink in, same time. And you don't have to be like, okay, I have to be exactly under the light, or like, when you're going from point A to point B, it's like, that's the reality of it. And working speeds, I'm talking like something that you can achieve right now. It's 1 Gbps. Again, the bandwidth has much more capability. The mobile phone right now can only go as high as 800 Mbps. Yes, mobile phone on a Wi-Fi now finally broke through that 400 Mbps speed, and I have provided the link down below of Linus Tech Tips and unboxing therapy, where you can see this speed is something achievable right now. And improvement in encryption, much better, like because the beam forming, you no longer have that, like okay, let's say this TV is receiving signal, and somebody's like on that side, they cannot receive it. The beam forming removes that issue, and encryption have been improved tremendously. And there are many things that, like latency, ping, and all that jazz, that makes sure routers is like, whoa, 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 what the hell is happening here? It's like somebody is piggybacking, it can detect that. And in enterprise grade, they have so many securities that I don't even want to think about it. So that's the reality of it. Like Li-Fi was stupid thing, is like you have to have basically infrared system, might as well use a proper infrared system. Problem with that is infrared is heat. So if they had, like, let's say 10 watt of infrared lamp, it's 10 watt of heater, and your skin will directly absorb it. So you will feel like you may be like, hey, my LED is 10 watt. Yeah, but it's in optical spectrum, the light bounces away from you, it does not feel hot. But infrared, you will feel hot. So that was the whole reality of it. It's like, I'm like genuinely surprised. Like, you have to use infrared, might as well make a, hey, we have infrared system, but does not sound cool. Just for that reason, they are like trolling the world. It's like it is LED, you can use LED fixture and LED agnostic and all that jazz. I'm like, why? Use the damn infrared. You have to have that for a backup. Make it into your primary system. It's like this happens, like somebody did not thought things far enough, and you're like, okay, I want that absolute security. Use this. Like, genuinely, it's cheaper. Use this, and faster and reliable. I'm like, even in my case, like only 3 mobile phones are connected via Wi-Fi. Everything else is Ethernet. So from my TV, both of the TV, my desktop, and the set-top box, even though all of them have Wi-Fi, I'm like, nope, Ethernet. So that's the reality of it. It was like a good idea, sounded cool, but it's just like solar roadway, sounded cool, 100% impractical. So this was my presentation on Li-Fi. What happened about it, like after 2015 and after 2016, after 2017, after 2020. So I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me an extra disappointment. Please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.